Welcome to the deep dive. Okay, so you've sent us this fascinating material on geospatial AI. GeoAI, it sounds like a pretty big deal, changing how we interpret the planet, right? Moving beyond just looking at maps.
Yeah, definitely. We're moving past static maps.
Okay, let's unpack this then. You shared these sources, I think, because you want that shortcut, the way to ask the planet these really complex questions,
Uh-huh.
questions that used to take, weeks of painful data work, and get answers fast, like
Yeah,
in minutes?
that's really the heart of it, yeah. The whole promise here, especially now it's becoming more accessible, is turning the planet from just a slideshow of images
Right,
into more of a conversation.
right.
Or maybe a collaborator. Instead of staring at layers for hours, trying to connect the dots yourself.
Which is so much work.
Exactly. You ask a clear question, a specific one, and the system does the heavy lifting, gives you a crisp, usable answer. So our mission today in this deep dive is really to shortcut that learning curve for you. We want to nail down what GeoAI actually is, how this new Ask Google Earth tool works in practice, and crucially, walk through some really powerful practical questions you can start asking pretty much right away.
Okay, let's start right there. The basics. For years, GIS, Geographic Information Systems, that was the standard, right? Many teams still use it. What's the fundamental difference? What's the actual leap GeoAI makes over that classical GIS?
Well, the key shift, the really big one, is adding reasoning.
Reasoning.
Yeah. Think of traditional mapping like a sophisticated way to stack layers. You put images, boundaries, maybe some points on top of each other, but you, the analyst, you have to do all the thinking. You figure out why one layer matters to another. GeoAI is different because it adds models that actually understand the content in that data. They can recognize things in imagery. They know about weather, terrain, infrastructure, even population signals. And then it connects all that stuff internally to answer, real questions that involve multiple factors.
I see. So it's not just drawing, say, a 50-meter circle around a point. The AI knows the thing inside is a school, and the circle is based on a storm drain.
Exactly. Precisely. And that difference just completely flips the workflow.
How so?
Think about classic GIS. What's your day like? Your unit of work is basically managing data, right? It's, I call it plumbing.
Yeah, plumbing sounds about right.
You're hunting down the right layers. You spend hours getting the projections to line up.
It's the projections. Don't get me started.
Right. Then you calculate intersections, buffer things, and then you manually pull all that into a spreadsheet to make sense of it. It's just laborious.
That plumbing analogy is perfect. I definitely remember that projection frustration. So GeoAI, it just skips all that data prep.
Yeah, pretty much. You articulate the need, the question, and the GeoAI handles the data discovery, the spatial joins, the calculations almost instantly. So the unit of work becomes the question. Like, where are storm drains within 50 meters of schools in Red Hook? The AI handles the search, the geometry, the intersection, all of it.
Wow. Okay, that is transformative. That's the difference between coding a complex database query versus just talking to a planetary analyst that doesn't need sleep. The sources you sent had some great examples, spotting algae in a river from an image.
Yep.
Or figuring out which neighborhoods are below a storm surge line, comparing mangrove forest by their, physical signature.
Exactly. All things that were technically possible before, but incredibly time-consuming and specialized. And automating that plumbing, it means the experts, the people whose time is valuable, can focus on the question and interpreting the results, not wrestling with data formats. Plus, GeoAI scales up naturally. That question about heat islands doesn't care about county lines. The same prompt that works for a few blocks in Brooklyn, you can run it across the whole Gulf Coast. Same process.
Okay, we've got the why. That reasoning part is clearly revolutionary, but, if I'm an emergency manager staring down a deadline, I need the how. Usually this kind of power means complicated, expensive software, right? How do non-GIS experts, the city planners, maybe even students, actually use this? You mentioned Ask Google Earth.
Yeah, that's the interface that really opens it up. Ask Google Earth. It's basically a chat window built right into Google Earth on the web, powered by Gemini. You just open the map, type your request.
Right there on the map.
Right there. And the AI agent figures out the steps, calls the models it needs, and boom, gives you back a map with layers and a table you can export.
Okay, the big win there seems to be lowering the barrier to entry massively. For years, you needed specialist skills for this kind of analysis. Now, you're saying analysts, students, they can tackle these serious spatial questions without needing to find shapefiles or write code.
Exactly. It makes high-quality spatial analysis much more routine, more accessible.
Right.
And the results appear right there. visually over the area you're looking at. It really shortens that loop from asking the question to actually understanding the answer and making a decision. Closing a road, sending help somewhere.
Okay, for someone listening now wanting to try this, let's walk through the steps. It sounds almost too simple.
It is pretty streamlined.
Yeah.
First, open Google Earth on the web,
Yeah.
earth.google.com, forward to the web. Make sure you're signed in.
Got it.
Second, start a new project. Think of that as your workspace. It saves your layers, your notes, the tables it generates.
Okay, project started.
Third, look for that little spark icon in the toolbar. That's the Ask Google Earth button. Click that, and the chat panel opens up.
And then the magic part, asking the question. Let's use that red hook example you mentioned. It really shows how it combines things. What's the exact prompt someone would type?
Right. You want the prompt to be clear, like field instructions. So try this. Map all storm drains located within 50 meters of public schools in Red Hook, Brooklyn.
Okay.
Create a table that lists each school and counts the drains within that distance. Add the schools and the drains as separate layers on the map.
Specific. And what tops up on the screen?
Almost immediately, you'll see yellow pins for the schools in Red Hook, then blue pins for just the storm drains that fall within that 50-meter buffer zone around each school.
Ah, so it shows the buffered ones.
Yep. And importantly, you get a table right there in the panel listing each school by name and the number of drains found nearby. And you can download that table.
That's a full risk assessment, multi-layered from one sentence. Incredible.
It really is.
That immediate feedback is key. And like you said, good prompts name the area, the objects, the relationship, the distance in this case, and what you want back. Layers, table. And then you could follow up, right? Like, okay, now filter to show only middle schoolers, or color code by risk.
Exactly. Follow-up prompts work great for refining, and then you save that project, share the link, and your whole team is looking at the same analysis instantly. Speeds things up a lot.
So maybe we should talk about the engine room. How does it actually do that? Take that sentence and generate that complex output.
Yeah, how does it figure it out? It's not just guessing, you said.
No, not at all. When you ask a question, it uses something called geospatial reasoning. It actually plans the operation. It breaks your request down into logical steps and then decides which specific Earth AI models and datasets it needs to combine to get the answer.
So it's not one giant AI brain, but more like an orchestrator calling on specialists.
Precisely. That's a great way to put it. It fuses together, broadly speaking, 3 families of capability.
Okay, what are they? First, you've got the imagery models. These are the ones that understand satellite scenes. I mean, understand. They don't just see pixels. They detect objects. Things like flooded roads, patches of algae, specific types of land cover.
Wait, hang on. It sees flooded road, not just dark patch of water. That's huge for emergency response. They need quick IDs.
It is huge. That semantic understanding is key. Then what about the human side of things?
Yeah, how does population fit in?
That's the second family, population models. These learn patterns in human activity, density, movement. Really useful for things like targeting aid to vulnerable communities and a very fine grain.
Especially if you need to cross-reference that with, say, infrastructure risk or a hazard zone.
Exactly. And the third piece.
The third piece is the environment models. These forecast complex things. Weather, obviously, but also floods, air quality, cyclones, time-sensitive stuff.
So the GOAI agent dynamically chains these together. For example, it might pull a hurricane forecast track.
Okay.
Intersect that with high-density population areas from the population model.
Right.
And then look for hospitals within the resulting high-risk zone using the infrastructure data, all from one initial query.
And the big advantage, connecting back to trust, you mentioned reproducibility. That seems critical if you're basing safety plans or budgets on this.
Absolutely critical. Because it's an orchestrated process, not a black box guess, you can rerun the same query with the same inputs later and get the exact same auditable output. That's massive for defensible decision-making.
Makes perfect sense.
Okay, so let's make this really concrete. The sources highlighted 5 really practical applications. These are the sort of aha moments showing the immediate value.
Yeah, let's hear them.
Okay, for urban planning risk, we've basically covered that. The storm drains near schools example. Output is that heat-colored map layer, maybe a ranked table. For environmental monitoring, think. Find harmful algae blooms in Florida rivers over the last month. The output. Polygons drawn right over the suspected bloom areas, maybe even a timeline view.
Very useful. What about disasters?
For disaster preparedness, this is really potent. The query might be, given this hurricane path, show counties with high population density and low elevation.
And the output.
An immediately actionable ranked list of counties, Maybe an overlay showing that most vulnerable corridor. Crisis management intelligence, fast.
Wow. Okay, two more.
Yep. Infrastructure management, think. Identify vegetation getting too close to major power lines in this region. The output could be segments of the line highlighted by risk level, maybe even draft text for a maintenance report.
Okay, really practical.
And finally, scientific comparison. A researcher could ask something like, show me all the mangrove forests globally that have a similar physical signature to the ones in the Mekong Delta. The output. A global map showing similar areas, maybe with similarity scores.
These aren't toy examples. These are templates for, yeah, critical decisions, often multi-million-dollar ones. So if the question is the new unit of work, how do we get good at asking? You mentioned prompts needing 3 parts.
Yeah, think of it like writing really clear field notes for that smart assistant. Good prompts generally have 3 reliable parts. First, scope. Where and when. Red Hook, Brooklyn, last 30 days. Be specific.
Okay, scope.
Second, measurement. What are you looking for and how do things relate? Storm drains within 50 meters of public schools. The relationship is key.
Measurement. Got it.
And third, output. How do you want the answer presented? Add layers to the map, create a table, export as GeoJSON. Tell it the format.
Scope, measurement, output. Simple enough. And a key tip, especially for critical stuff, is verification.
Definitely. Ask the agent to cite its data sources. It should list them in the response panel. That transparency lets you quickly check, builds trust.
Good practice.
And maybe use a staged approach, especially when you're starting.
Yeah.
Test a narrow query first. Map schools and drains just in Red Hook. Check the result. Does it look right?
Yeah.
Once you trust that pattern, then broaden it. Okay, now do all 5 boroughs. It helps maintain quality as you scale up.
That speed is amazing, but yeah, fast answers need careful handling. The sources definitely mentioned the dual use issue, the same tool.
Yeah, it's a reality. The same intelligence that helps plan relief efforts could potentially be misused. So responsible design is paramount.
What do those guardrails look like in practice?
Well, first, it relies heavily on thoughtful policy and system design. Prioritize public data, public imagery, published boundaries, anonymize stats by default. If private data is absolutely needed, access has to be super strict, logged, controlled. And critically, you need that audit log of every query run and every output generated.
So you can trace who asked what when.
Exactly. And that log connects to the other main guardrail, explainability. The system needs to explain its steps, cite its sources.
Why is that so important?
Because that transparency allows humans to review the process. You can look at the steps and spot potential errors or biases in the data or the request. It makes the whole thing defensible, ethically and practically. Responsible use becomes a daily practice, not an afterthought.
Okay, so wrapping this up, what's the big picture here? We've seen GeoAI turn these really complex, sometimes weeks-long GIS tasks into, well, conversations, auditable conversations. It feels like it's democratizing this high-level spatial analysis for, well, almost anyone who needs it. Planners, managers, health officials.
That's a good way to put it. Maps have come a long way, haven't they? From paper posters to those interactive slippy maps online.
Yeah.
And now with GeoAI, they're becoming collaborators, partners in analysis, teams, whether city planning or utilities or emergency response. They can finally start moving at the speed the data actually arrives, proactively mapping risks, not just reacting.
The world throws so much information at us, right? Satellite images, forecasts, population data. It's faster than any human team can really process on their own. Geospatial AI looks like the way we start to keep pace, turning all those numbers and predictions into actual decisions on timelines that matter.
That's the goal.
So if your team out there can make better, faster decisions with clearer spatial answers, well, now you have a much better idea how to get them. The challenge for you now is, what better question will you ask the planet today?